Can you tell me to start before I do? Welcome to Pragyan 21's first exhibit. Tonight, we will witness the culmination of a project that took over a decade to complete. Prosthesis, a gargantuan two-story tall tetrapod exoskeleton, was built with the intention of advancing the nascent sport of mech racing. To date, it holds the Guinness World Record for the largest tetrapod exoskeleton racing machine. Pragyan is incredibly ecstatic to introduce the man behind the machine, Mr. Jonathan Tippett. During the demonstration, you can post your questions on the live chat. We welcome you, sir. The stage is all yours.
Thank you so much. It is a real pleasure to be here. It's always gratifying to know that my work has reached across the globe. And I've spoken at many conferences over the years, but this is the first virtual one. So I appreciate your patience and all the setup that's taken place to make this happen. It's a real pleasure to be able to present today. The machine behind me is the machine that you just heard described. It is the world's first purpose-built all-terrain exoskeleton made specifically for competitive sport. It's called Prosthesis, the anti-robot, and it has a long origin story that I'm going to share with you tonight, because most of the questions I get asked when people see it are, what is it, why did you build it, and how does it work? So I'm going to cover some of those topics in the next half hour. The first question is, what is it? Well, I can give you a little bit of a tour. The machine is a four-legged, electric-powered, hydraulically actuated exoskeleton. It's built with off-road capabilities so that ultimately the objective is to create a sports league where elite athletes will strap into these machines and go head-to-head in races over complex technical obstacle courses. So the design constraints that went into developing the machine were very different to constraints that went into other hydraulic machinery or other exoskeletons. The question of why is probably the most important one, because it's the source of the motivation and the dedication that it's taken to get to this point. The project really had its origin back in 2003 when I first went to a huge arts festival in the Nevada desert in America called Burning Man. And this event showcases some of the most incredible creative work on the planet. Giant animated sculptures, mind-blowing light shows. And it really is an inspiring place to be a creative person. And I, as a mechanical engineer, fundamentally consider myself a creative person. That's a creative pursuit, first and foremost. And I have a history living on the west coast of Canada here of mountain biking and snowboarding and riding motorcycles. I also practice martial arts and do hand drumming. So it's always been very important to me to be connected with my body and my physicality. And I've always recognized the value of those moments where you're participating in an activity that has taken years to achieve some level of skill or even mastery. Not that I would claim to be a master in any of those in my own right, but when you find yourself in these situations where there's a little bit of personal risk, like you're mountain biking down a slope or you're riding a motorcycle, and your safety is dependent upon your focus and the skill and training that you've been doing over many years. There's a little bit of adrenaline involved, and there's an extreme mental focus, and there's a full body participation. And I realized that those are some of the most gratifying moments in my life, and I wanted to develop a machine that you could operate that created those kind of experiences. I wanted to expand the scope of human experience. You know, it's the same way somebody strapped planks to their feet one day and said, I want to slide down that snowy mountain. And, you know, this is kind of what gives rise to a lot of sport, especially adventure sport, is just people seeking new challenges. And I wanted to create a machine that required full body operation. I wanted it to have legs because as a human, I've got 2 arms and 2 legs, so it sort of naturally fits that the machine is going to be a 4-legged machine. And I wanted it to be entirely human controlled. No automation, no gyros. This machine is not a robot. That's why its full name is Prosthesis, the anti-robot. It's sort of its secret sub-name. And it's not because I don't like robots. I love robots. I'm a mechanical engineer. But the need to create something that required skill was fundamental. And there's so much in our lives that is automated and made virtual and sort of taken over for us by technology in an increasing rate that I thought it was important to make this machine, even though it is high tech and only made possible by cutting edge technology, it still keeps the human at the core. And that was the fundamental message of the entire project, is to use technology to enhance and expand human skill and to keep the human in the loop, control-wise. And in a metaphorical sense, it sort of represents, it speaks to how technology can amplify our actions. And when you're in there and there are people around you looking up in terror, you appreciate how important it is to take seriously the responsibility that that power gives you when technology amplifies your ability to affect your environment or your immediate surroundings. So I set about making a machine that sort of fit all these criteria, and it never was intended to be the largest 4-legged exoskeleton on the planet. It just kind of came out that way through the engineering process. Another thing that people wonder about is it modeled after some kind of beast? It's a 4-legged machine, and it sort of walks like a gorilla, down on all fours. It's short, it's not long like quadrupeds, like dogs or cats. But the answer is no. There was no mimicry, no biomimicry at all. However, it has a biological, lifelike essence to it because myself and biology are both operating to the same constraints. The laws of physics dictate optimal design. Nature has a slightly longer timetable and a slightly larger budget than myself. So my creations look a little clunky compared to, say, the legs of a dinosaur or a cheetah. But there's a convergence that happens, I think, and in good design, often I adhere to the adage that if it's beautiful, it's probably going to work well. That's certainly how it works with nature. So the actual design of this machine was driven by the need for simplicity and lightweight. The architecture that you see here with these are 2 legs on one side, and you'll see they're on a common axis. And that was just for simplicity. I didn't want to have legs separated by a long distance like on dogs and cats and most quadrupeds, because then you have a long torso, which is going to have stresses and structural issues. It's going to add weight. It's going to make walking more complex. If you have all your legs on one axis, it's really easy to swap from your inside legs to your outside legs. In some ways, it's less a quadruped and more 2 bipeds next to each other. And the pilot is inside controlling all 4 of those legs and has to coordinate them. Now, I wish I had more room to run around here and I could really show you some of the different gaits, but one of the joys of this machine and one of the great challenges of this machine has been learning how to operate it. And when I first built it in 2017, it came out of the lab and it was barely functional. The control system was many iterations older than this. And because the machine is so not anthropomorphic, the balance is completely different. The joint configuration is completely different. it took me literally almost a year to learn how to take a step. But I mean, that was just the sort of tip of the iceberg in terms of the journey, because leading up to this creation was a number of other creations, and I can take you on a short visit to its predecessor, which was an earlier walking machine that I built called the Mondo Spider. This machine here is an 8-legged, purely mechanical walking machine that is operated from inside by a pilot using these 2 levers and has battery power. So that was the machine that I sort of learned how to build legs and learned got a sort of taste for the joy of operating a walking machine. It was built here at the Eat Art Foundation, which is an educational charity that I co-founded back in 2007 to promote the adoption of clean tech and the creative use of engineering. And through building the Spider, that was the seed of the inspiration for this. And also, you'll see a lot of parallels in the tube structure design. So from that point, I built a prototype leg over the course of 5 years between 2010 and 2015. I built 1 prototype leg, developed a control system, developed the basic leg architecture, again, driven by the need for simplicity. The leg is what I call a lightning bolt design. It just zigs and zags and zigs. The simplest walking machine you can make has legs that swing back and forth and change length. So that was my goal. And I ended up going through a whole bunch of designs and ended up with this configuration for ease of fabrication and also just for appeal. I was a big fan of dinosaurs as a kid, so the idea of coming up with a machine that looks kind of like a giant mechanical dinosaur had a lot of sway. And it was around then at 2015 when I had 1 prototype leg developed that I partnered with Furrion. Furrion is a large multinational engineering design company with a focus on electronics and appliances and green tech. And they recognized the potential for this technology, and we formed Furrion Exobionics together, which is a Canadian R&D initiative specifically aimed at developing this machine and other ones like it. So that was the beginning of the journey in terms of actually building this machine behind me. I think up until then, I had no plan to actually get the machine completed. And now that we've been out in the field for 4 years, we've learned a lot about the difference between your CAD model and your computer simulations and the fantasies you have when you're fueling yourself with inspiration and the reality of building a 4,000 kilogram, 200 horsepower human piloted walking machine. And there was a lot of work done over many years to the control system, to the suspension system, to the ergonomics of the interface, to the power plant. And it's only about a year ago that it all started to converge, and we started to arrive at the form factor and the technology that we now have here. So I think that's probably a good segue to demonstrate the machine, because that's really the funnest part. This entire project was created for the purpose of the experience of getting in this machine. Now, if I had my way in the world, I would be traveling the globe, giving opportunities to people all around the world to try it, because really that's the offering that I'm hoping to make to the human condition, if you will. But for now, it will have to suffice to see a demonstration on your computer screen. So I'm going to get in the machine and stand up in the confines of our lab here. The machine's in the Eat Art laboratory for about 3 or 4 months over the winter. We're doing some upgrades to the interface and the ergonomics and the battery to get it ready for a set of pilots that are coming in the spring or probably late summer with the way COVID restrictions are going Excuse me, they signed up for pilot training last summer. And it's an exciting moment in the history of the development of the sport of mech racing because it's the first time that we've just strapped strangers into the machine. Up until now, it's been myself and a select few people from the team who actually made it happen and put in their time and energy to build the machine that have had a chance to strap in. So we're really excited to welcome that batch of alpha mech pilots and start learning about the human side of mech sports. So without further intro, let me climb in there and show you how this thing operates. The machine has 2 hydraulic pumps, and the reason for that was because I couldn't find an electric motor big enough to run 1 hydraulic pump, and because a redundant power plant is a little more reliable. So the pilot slides in here, makes himself comfortable. It's a tight squeeze getting in, but once you're through the roof, you kind of emerge into a human-shaped space and find spots to clip in your feet, secure your legs, clamp your arms, and grip the grips. One grip activates the pumps, and the other grip activates the controls. So what I'm going to do now is I'm just going to stand up and give you a sense of how dynamic the machine is, and then I'll try and show you how my body connects to the machine on a limb-for-limb basis. So you can balance the machine by rocking back and forth, and really quite powerful. One of the things we've been learning is exactly what the best way to teach pilot skills is. So we've been doing drills. One of the drills is balancing on 2 legs. Which is a great way to practice when you're walking like a gorilla, which requires you to balance on 2 legs and swing the other 2 legs forward. So you can see here, let's see if I can walk it a little closer to the bit of a tight squeeze. You can see the outside legs are controlled by my arms. The inside legs are controlled by my legs, my knees, can be controlled from the hand grip here. So these prevent you from falling, particularly when you're training, but then they can be brought up out of the way for if you need a little more freedom. They can also be they can be used to lift you back up if you fall over, although most positions you can get up just by using the legs. And there's another set of bumper bars on the rear that are also controlled from the hand grip here. And then, of course, you just got to learn how to punch the machine. Whew. Even after 4 years, every time I get in, it's an adrenaline rush. Particularly when you're inside a lab full of expensive equipment and you can't see behind yourself. But that's all part of the training. You know, the process of getting to know the behavior of the machine and the nature of the machine is part of the reward. So I thought maybe I could take a little tour around the machine. Now that you've seen it move, it might make a little more sense to look at it. Oftentimes people see it crouched down and they can't even really make out what parts move and what parts don't. So you can see the leg structure there is this very simple down, out, and down, where you've got a hip joint up here controlled by the pilot's shoulders on the outside and by the pilot's hips on the inside. And then you've got this knee structure, which is where the suspension is integrated. And this is ultra high performance, custom spec'd racing truck grade suspension with 0.5 meter of travel that not only soaks up the hits when you land, but it also adapts to the terrain and gives the pilot a little bit of cushion, just in terms of their experience inside the machine. Because you can imagine when it starts jumping around like that, it gets a little bumpy inside. The interface up here is kind of the heart of the machine. That is where the pilot connects to the machine. It's a full body exoskeletal interface. You've got spots for your arms and then spots for your legs. And it's suspended and cushioned to protect the pilot from impacts, and just the jostling of operating the machine makes it more challenging to operate the machine. So one of the challenges with the design of this machine was developing not only a control system, but also the ergonomics of how to secure the pilot so that they weren't just ragdolling around inside there. And a lot of that was done in the early development stages with the first prototype leg, which we called the alpha leg. And we translated that into some of the technology in this interface. So as a prototype, we're pretty excited. We're pretty satisfied. It's been a long journey just to get it where it is now, and we still feel like there's a lot of potential in what this machine can do and what I can do or anyone else can do as a pilot. That's the great thing about mech sports, or even powered exoskeletons irrespective of the application, because it's not just about sport, it's about all of the other things, the versatility of a human-controlled machine with so much versatility. We intended this just for sport, but it's already come in handy. We've rescued trucks out of the mud. We've moved heavy weights. The machine can lift its own trailer that it travels on. It can lift about 1,000 kilograms. So as a proof of concept, the future for this machine is just to continue to explore and learn. There's definitely plans in the books to build a second generation mech suit. The ultimate vision is a world filled with giant powered exoskeletons that are for sports and recreation, search and rescue, forestry, mining, agriculture, you name it. There's any number of applications that this type of technology could be used in. But in the near future, we plan to take a small step forward. The next generation mech suit will be about 2/3 the size, because as much as we are grateful to have been awarded the title of largest tetrapod exoskeleton by the Guinness World Record folks, that wasn't the real goal, and it's a big machine to move around. So the next one will be about 2/3 the size, half the weight, and probably twice the power, because battery technology has come a long way since this pack was designed in the sort of around 2010. We estimate without too much trouble we could get about double the power for the same amount of weight. So we're extremely excited for the next generation of mech suit. The number of things that we've learned from this will make the next machine a completely quantum leap forward. It will probably be able to jump on the spot. And from that point, I think we're really going to start learning a lot about the potential for this type of technology, not only in a sports and entertainment context, but through all the other applications that sort of come out of the woodwork in the process. So the future is bright. We really appreciate any opportunity to share the story with the world, because that's such a big part of how this is going to be successful. Having the encouragement and the audience for the first application of sport is crucial to developing the technology, and in that sporting competitive context, it will be incubated beyond that. So thank you so much for having me on to come and give this presentation, and I hope it's been educational and entertaining. I'm happy to field questions from anyone in the audience, and look forward to getting any feedback on our social media. I'm sure you can get it through the links on the page. So I hand the floor back to our Pragyan hosts. Thank you very much.
That demo was truly enlightening. It was also very incredible to watch, all the arm movement and stuff. It was great. Um, it is time to clear any lingering doubts or questions you may have about prosthesis. Um, we do have a question. You said it took over a decade for you and your team to get this done completely. I'm sure there were a lot of hoops you had to jump through, and the odds must have stacked up against you a lot. Was there any point in there where you lost hope, or you thought it was too much?
The short answer is no. There were a lot of points where I was really stressed, and there were a lot of sacrifices made, frayed relationships, missed opportunities in other parts of my life. I lived a very devoted existence to the completion of this machine. I was working as a biomedical engineer designing brain implants, which was a great career with a long path forward that I put aside to complete this project. About halfway through, I went down to working 3 days a week at that job so I could focus entirely on this before we even had any funding. Finally, in 2015, we got funding. I was able to quit my job, hire my friends. But there were no shortage of roadblocks and hurdles. And that was part of what made it so rewarding. Is if it worked right out of the box, it would almost be disappointing. The challenge is part of the fun.
Um, there was also another question we had. In the video, you did say that you said the successor was going to be two-thirds smaller and half the weight. So I take it that work has begun on it?
Pardon me?
I'm sorry, I was saying the work has begun on building the successor.
Not building it. The design process has begun. You know, every time we learn something about what we want to do to this machine, we either do it on this machine or we put it on the list of upgrades for Rev 2. So, you know, in terms of developing the power plant and thinking about the next hydraulic circuit and thinking about the structure, how we can make the structure more efficient and the overall architecture. At very early stages, you know, it's not like we have CAD models of it or anything at this stage, but sort of sketches and calculations are underway to make sure that we can achieve those high-level goals.
So a question from the audience. Um, Ashi Singh asks, how to get started in such projects? Any advice on that?
That's a great question. That is a very important question because when you see something of this scale and the costs involved and the years that went into it, it seems totally daunting and unsurmountable. And I mean, if you asked me 15 years ago, would I commit to this path of devotion and sacrifice and you know, living with this a singular purpose? I'm not sure that I would have been able to say yes to how the things have evolved. But the important thing is to set out with something you're passionate about. And if you have something you're passionate about, what I did, the first thing I did wasn't raise money. I just started doing it with whatever resources I had. I had my own skills as an engineer, so I started doing the engineering. Founding the Eat Art Foundation was absolutely crucial. Bringing together a community of like-minded, inspired people with a mosaic of skills. There's fabricators, there's carpenters, there's electronics engineers, there's mechanical engineers. I sponsored dozens of student teams over the year at our local university. University of British Columbia have been an amazing partner through this project. We've got another student team working on it right now, upgrading the pilot suspension system. And I think that's been the most important thing, because once you build a community, whether it's a formal educational charity like we chose to do, or whether it's just a club or just a team of crazy people who have a shared vision, that's when the power starts to swirl and grow and feed on itself. This person's got this tool, this person's got some space, this person knows someone else who's got a certain skill, and it just kind of starts to build. And as the project grows in size and builds momentum, it attracts more people. In our case, it started to attract corporate sponsors who started donating parts, eventually culminating in attracting Furion, who really came in with the funding we needed to build the entire machine, which was never planned. But all of the good fortune that befell us on the way was a function of our tireless devotion to the vision. And whatever spare money, spare time, and spare headspace we had, we put towards making this happen. So community and passion are the two most important ingredients. Everything else gets drawn in from there.
The time remaining permits just one last question. How did the idea spark in your mind?
I can actually name the exact moment where the first seed of the idea came. It was when I was at the Burning Man Festival in Nevada, wandering through. It's a giant festival. There's 50,000 people there, so they build a small city. So I'm wandering through the city in the plains of the desert, lights going off, flames erupting, music pounding, and I walked. There's a lot of sculpture there, and I walked past this one sculpture. It was about 10 feet tall. It was a pair of dinosaur legs, just cut off at the waist, And I saw these dinosaur legs. It was made of car parts, wrenches and gears and pulleys and whatnot. And I also have a background in sculpture, so I was attracted to it as a sculptor. And I looked at it, and it had this very mechanistic air about it. And I looked closer, and I realized that it wasn't functional. It was just made of mechanical parts. And my engineering mind immediately said, well, wouldn't that be cool if those legs worked? And because it didn't have a body on top, it was just a platform, I thought, wouldn't that be cool if those legs worked and you could sit on top of it and you could operate them, but they weren't automatic. You had to operate them one for one. It was like you had to practice and use skill. And that was kind of the moment where I thought that would be the coolest thing ever, is a full body walking machine that you had to control that was giant. And the rest is history.
And that's it for today. Thank you, Mr. Tippett. It was an exquisite demonstration. I'm sure all of us enjoyed it. Thank you to all of our audience for joining us tonight. Until next time, good night, stay safe, and let's celebrate technology.
Thanks so much. Good night.
Good night.